Today we're going to talk about a brief high-level concept about IPv4 addressing. IPv4 addressing is a 32-bit number, and it's divided into 4 octets, and octets are 8 bits. Each octet is an 8-bit. That's what the word octet comes from, 8 bits. And that's how they are structured, with the formula of 2 to the power of n. So if 2 to the power of 0 is 1, 2 to the power of 1 is 1, 2. 2 to the power of 2 is 4, and so on. If you want to represent a decimal number 10, you would put or enable the binary bit 8 and 2, and that would sum up to a 10. Similarly, if you want to write the rest of the octets, let's take this one. You're going to do 1, 2, 4, 8, 16, 32, 64, 128. So 1 is going to be 0, 0, 0, 0, 0, 0, 0, 1. And a 3 is going to be 2 and a 1, and so on and so forth. Let's take the example of a network. Here in this example, we're taking, let's say you're given a network of 10.0.0.0/8. /8 is a prefix length. It's called a prefix length. And if you were to write this, it's going to be written 10.0.0.0.255, and 255 is the mask. So you're masking the first octet, and you're leaving the second, third, and fourth octet for addressing. How do we address? Here's an example. So if this is the network that's given to you, you could take this network and call the first octet a country octet. You're representing country or a network, The second octet you can call state, and the third octet you can call city. So you can have, in this given network that you got, it's a private network, 10.network, you can represent 255 states, 255 cities, and on the fourth octet you can have 255 computers, or representations, or houses, or whatever you want to call it in this example. So when you do that, these are called the subnets. This is the major network. These are the subnets, second and third, because you got a /8. And your mask is /24. So you're masking the first 3 octets because it's the network, subnet, and subnet. You're leaving the last octet, the fourth one, for host addressing or computer addressing. Okay. Now, why do we need to mask? Why do we need to do the masking here? And why do we need to do the unmask? So here's the explanation for that. So in the first example, we take source address, which is our address, 10.1.1, and /24, which is our computer address, let's say. And our destination address is, we're trying to talk to somebody at 10.1.1, 10.1.1.10. That automatically tells you or tells the computer that the destination address that you're trying to send the packet is on the same network. Why? Because you have configured on that computer this address /24, right? First 3 octets /24. So the destination is exactly the same as your source. So that tells your computer that it's the same network and the same subnet. Therefore, I'm going to send directly to the computer. It's the same city. So it's going to, in the real life, it's going to go to either a switch or a directly connected computer. Now, in the second example, the source is your computer again, that you have the address 10.1.1/24. /24 means you have the network and the subnet on the first 3 octets. Your destination address is 10.1.1.2. This is not same, right? This is not same, it's different. So that tells your computer the destination that where you were trying to send the packet is not same, so I'm not going to send it to the broadcast. I'm going to send it to the default gateway that you have configured. So it sends to the router now. It's a different city, so you're going to the airport to go to the different city. 2 and 3 exactly the same. Source is your address. Destination now again is a different address. So you're not going to send to the same set network. You're going to send it to a default router, default gateway, a different city. City was different here, and city was different here as well. In this case, a state is different altogether. All right, and the last example, which is again, source is your address, and the destination is a Google DNS. And it obviously does not match. So he's going to send the packet to the default gateway. So that's why you mask, you tell your computer whether the destination packet is on the same network or it's not on the same network. And that's how the computer tells whether to send it to the default gateway or not. If all of your communication is on the same network, you do not have to send or configure default gateways at all. That is a brief overview of how IP addressing and masking works.